So once again, let us state the Bohr's postulates. First postulate says every electron will every electron will revolve around the nucleus in discrete quantized orbits called stationary orbits. Second one, the angular momentum of electron in the stationary orbit is constant. It will be equal to the integral multiples of the parameter h by 2 pi. That n is equal to 1, 2, 3 stands for the principal quantum number of the orbit in which the electron is revolving. And third one, energy of electron in a stationary orbit is constant. Emission or absorption of energy will take place only during the transition of electron from one orbit to another orbit. The amount of energy emitted or absorbed will be equal to the difference in energies of those two orbits between which the transition takes place, and the frequency is the difference in energy by Planck's constant. Wave number, of course, is reciprocal of wavelength, which is equal to nu by c. That's what we discussed yesterday. Now we'll continue. Already radius of Bohr's orbit also we have done. I'll just do it once and continue with other things. So before we go into them, I'll just give you a few important points for understanding these derivations. First and foremost one, directly I took the expressions yesterday, but I'm giving you once again those formulae. These are the two charges, say nucleus and electron. This is the Coulombian force of attraction, Fc. So the Coulombian force of attraction between these two charges is 1 by 4 pi epsilon 0 q1 q2 by r square. Epsilon 0 stands for the permittivity of vacuum, whose value is 1 by 36 pi into 10 to the power of minus 9 farad meter inverse. This is what we are going to use. Another one is, if any two charges, this is positive charge and here is negative charge, the attractive force will be pulling them together through a distance when they are at distance r, but we don't want them to move together. Means the electron revolving around the nucleus is not falling into the nucleus. I said Rutherford failed in explaining the stability of the atom because of this drawback only. So to overcome that, Bohr suggested the stationary orbits. Means how could he say that this is from the electrostatic potential energy? Sun is pulling all the planets with the gravitational force, but the planets are not falling into the sun. The reason is every planet will maintain a fixed distance with respect to the sun in its orbit, because the sun planet system will possess gravitational potential energy. In the same manner, this positive charge and negative charge, even though attractive force is there, they are prevented from approaching each other because of the stability of electron in its orbit, which prevents it from falling into the nucleus. So that potential energy is given by the formula, of course, minus q1 q2 by 4 pi epsilon 0 r. How will you get this? Potential energy is nothing but integral dw, that is integral f dx. So this f is nothing but q1 q2 by 4 pi epsilon 0, distance is x, so x square into dx. Limits are from some infinity to r. Then you will get this formula. This is the derivation. This is how we get this formula. Then kinetic energy is given by the formula V into Q2. V is the electric potential of charge Q1 and other charge is Q2. So if you put this, we'll be getting it as Q1 Q2 by 8 pi epsilon 0 R. How we get this? This is the formula for kinetic energy of a charged particle Q2, which is influenced by the electric potential of charge Q1. So we get this formula Q is equal to, K is equal to V into Q2. And this finally on derivation comes out to be Q1 Q2 by 8 pi epsilon 0 R. So you must remember the Coulombian force. You must remember the expression for potential energy. You must remember the expression for kinetic energy. So if you can understand these, if you can have these three formulae in your mind, then the derivation of these various relations, the formulae what we are going to get now will be very, very, very easy. Have you noted these expressions? Yeah, Swarna,
Sir,
have you noted these expressions now?
sir, writing, sir.
One is Coulombian force of attraction. Second one is electrostatic potential energy between the charges Q1 and Q2. Third one is the
Yes.
kinetic energy of Q2 due to the potential of Q1.
Yes, sir.
Kinetic energy of Q2 due to the potential of Q1. This is potential energy of the stable configuration of charges Q1 and Q2. So if you can know these expressions, rest of our work will be very easy. Pranav?
Yes, sir.
Yeah, have
Yes,
you
sir.
noted down?
1 minute, sir.
Okay. Shall we proceed?
Yes, sir.
Okay.
Yes, sir.
Okay. So, Bohr's orbital radius. As I said yesterday, here is a nucleus. This electron. Nucleus has got a charge plus Ze, and the Coulombian force will be acting along the radius. This is the speed v and mass m. So the Coulombian force of electrostatic attraction of nucleus on the electron is given by Q1 is Ze, Q2 is E by 4 pi epsilon 0 r square. So it comes out to be Ze square by 4 pi epsilon 0 r square. Then I said this will be equal to, yes, the centripetal force
Yes, sir.
needed for the electron to move around the nucleus. So here, this R can be cancelled, and the second postulate, Bohr's second postulate, gave us a relation MVR is equal to NH by 2 pi. From this, V is equal to, it is NH by 2 pi MV. So just substitute this value of V in this expression. We'll be getting it as M into V square N square H square by 4 pi square M square V square will be equal to ZE square by 4 pi epsilon 0 R. So finally, we will be getting the expression for radius as S N square H square epsilon 0 by pi M ZE square. Swarna, am I right?
Yes, sir.
Integration part I am skipping, very important. So the radius of the orbit with the principal quantum number n is given by n square h square epsilon 0 by pi m ZE square. Here it is V is equal to NH by 2 pi m R. Yes. So cancelling corresponding terms, you are left with the formula for radius of orbit with the principal quantum number n as n square h square epsilon 0 by pi m ZE square. Noted?
Yes, sir.
Now you should tell.
1 minute.
Hmm. You have to remember this expression. You remember this
Yes,
concept,
sir.
these two concepts you remember, and remember this expression.
Yes, sir.
Rana, okay?
Done, sir.
Good. So I got Rn is equal to n square h square epsilon 0 by pi m ZE square. Here h Planck's constant, epsilon 0 permittivity of vacuum, m mass of the electron, E electronic charge. So the variables are only n and h. Therefore I can write Rn is equal to, it is substituting all the values, we'll be getting it as 0.529 multiplied by n square by z angstrom units. So for hydrogen atom, atomic number is 1. So the radius of orbit with the principal quantum number n is given by 0.53 n square. 0.529 is approximated as 0.53 angstrom units. So for the orbit with principal quantum number 1, first orbit I mean. So the radius of first orbit of hydrogen atom is given by 0.53 angstrom units, and R2 is 0.53 into 4. R3 is 0.53 into 9, and so on, correct? For other atoms, if you are asked, you should take this expression. 0.53 into n square by z. This is for other atoms. Okay. Very important. Chances to get questions are there from this topic.
Yes, sir.
Yes. Now, shall we proceed?
Done, sir.
Then see the second postulate. Implied MVR is equal to NH by 2 pi. Therefore, speed of electron in the Bohr's orbit what is that sound, ma?
Sir?
Mute your mic because a lot of disturbance is coming, right?
No, sir. Fan, sir. I will off.
Yeah, better mute it.
Yes,
Mute
sir.
your microphone. Whenever I ask you, switch on and talk to me, right?
Yes, sir.
Yeah, better do that. So that these extra
Yes,
sounds
sir.
are prevented. So from this
Yes,
V we will get NH by 2 pi MR, correct? So for first orbit, very important deduction we'll get. N is equal to 1. R is equal to 0.53 angstrom units. So V1 will come out to be 1 into 6.6 into 10 to the power of minus 34 by 2 pi into mass, electron mass, 9 into 10 to the power of minus 31, radius 0.53 into 10 to the power of minus 10. Angstrom units, you should convert it into meters. So on simplification, this comes out to be 3 into 10 to the power of 8 by 137. 3 into 10 to the power of 8 is nothing but speed of light. Therefore, the speed of electron in the first orbit of hydrogen atom is C by 137. Simple. Very, 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 very important deduction. You must remember it. So the speed of electron in the first orbit of hydrogen atom, I calculated using this formula. So it is N is 1.666 into 10 to the power of minus 34, the value of Planck's constant by 2 pi, mass of electron 9 into 10 to the power of minus 31 into R 0.53 into 10 to the power of minus 10. So on substitution, we will be getting it as V1 is equal to C by 137. So the speed of electron in the first orbit of hydrogen atom will be 137 times less than the speed of light. C 3 into 10 to the power of 8 meters second inverse is the speed of light in vacuum. So if you want in other orbits, speed of electron in other orbits of hydrogen atom, it is N into C by 137, correct? Here N value is 1, whereas for other orbits, it should be N into C by 137, means for second orbit, it is 2 into C by 137, third orbit, 3 into C by 137 and so on. So from the expressions of radius and speed, we are going to get two ratios. You have to remember them. You have to remember, right? 5-6 times. You'll remember them permanently. Shall I go to the next? Finish the?
Yes, sir.
Okay. Swarna finished?
Yes, sir.
Okay. You can put note. R1 is to R2 is to R3 and so on is N1 square is to N2 square is to N3 square and so on, because Rn varies directly as N square. So the answer is ratio of radii of the orbits in the hydrogen atom is ratio of squares of natural numbers that is 1:4:9 and so on. The second important one, V is equal to N into C by 137. So the ratio of speeds of electrons in the different orbitals of hydrogen atom will be equal to the ratio of principal quantum numbers, that is 1:2:3, etc. You have to remember it. Very, 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 very important note. These things should be done on the spot. We should not think. We should not waste much time on such concepts. Directly read the question and put the answer. So they should be stored in memory. Shall I clear? Have you noted?
Yes, sir.
Okay.
Yes.
Swarna.
Yes, sir.
Then, very important part of this, energy of electron in the orbit. The total energy of electron in an orbit with the principal quantum number n is the sum of potential and kinetic energies. Electron possesses potential energy by virtue of its stable configuration in the orbit against the Coulombian attractive force. Electron possesses kinetic energy by virtue of its orbital motion. Please write this. Write this, ma. Electron possesses the potential energy by virtue of its stability in the orbit against the Coulombian attractive force. Next, it possesses kinetic energy. By virtue of its orbital motion, with a speed v. So total energy is given by U plus K. Now this is U. I told you, U is integral dW. Limits are from infinity to R. Electron in the space at infinite distance is brought and placed inside in the orbit. So this is integral f dx. F is nothing but Coulombian force, Z square by 4 pi epsilon 0 x square dx. So finally, integral dx by x square is minus 1 by x. That's how we'll get, applying the limits and all, it is minus Z square by 4 pi epsilon 0 r is the expression for potential energy of electron in the orbit with radius r. Next, kinetic energy. Please note it down. So we have the Bohr's first concept. The required centripetal force mv square by r is the Coulombian force of attraction given by Z square by 4 pi epsilon 0 r square. So this r is cancelled. Multiply this on both sides with the half. So we'll get k is equal to half mv square. is equal to ZE square by 8 pi epsilon 0 R. So this is the expression for kinetic energy. Now, total energy is equal to U plus K. If you take LCM and simplify, then I'll get 8 pi epsilon 0 R will be the LCM. Here I'll get minus 2 plus 1. Therefore, final expression for energy is minus ZE square by 8 pi epsilon 0 R. This is the final expression for energy of electron in the orbit with radius R. So we have these two expressions are important. Expressions for potential and kinetic energies are important in this. If you add them, take LCM and simplify, this will be your final formula for total energy of electron given by minus ZE square by 8 epsilon 0 R. Now what we are going to do is, we will substitute the value of radius of orbit with the principal quantum number n in this expression to get the final formula for the energy of electron. Shall I remove this? Have you noted?
Yes, sir.
Swarna? Swarna? Swarna is not talking. Okay. So, I got E is equal to minus ZE square by 8 pi epsilon 0 into 1 by R. So, what is this R here? N square H square epsilon 0 by pi m ZE square. Already we derived it. So, if you substitute in this, I'll get the energy of electron in the orbit with the principal quantum number n. I'm not showing the simplification. So it is minus ZE square by 8 pi epsilon 0 into pi m ZE square by n square H square epsilon 0. So the simplified formula for the energy of electron in the orbit with the principal quantum number n is given by this pi is cancelled here. So any more cancellations? Yes, it is minus m z square e power 4 by 8 epsilon 0 square h square n square. I think all the things are taken care. M z square e power 4 by 8 epsilon 0 square h square n square. This expression I am going to write again as, all these things you need for board, but for JE or NEET, we need only final expressions. So En can be now written as m z square e power 4 by 8 epsilon 0 square h square into minus 1 by n square. Mz square e power 4 by 8 epsilon 0 square h square into minus 1 by n square. You substitute all these values and simplify. This comes out to be 13.6 z square into minus 1 by n square in electron volts. This expression you will be getting the energy in joules. Whereas if you convert this, substitute the value of mass of electron, 9 into 10 to the power of minus 31, E 1.6 in 10 to the power of minus 19, epsilon 0 value, permittivity of vacuum value is 8.8 into 10 to the power of minus 12 Farad meter inverse. Then H, Planck's constant, 6.6 into 10 to the power of minus 34 joule seconds. So if you substitute all those values in this expression and simplify and convert that joules into electron volts, 1 electron volt is 1.6 into 10 to the power of minus 19 joules. So making all these values and solving it in electron volts, this is the final expression we get, which is to be remembered by you. En is equal to 13.6 into Z square multiplied by minus 1 by N square. This also implies En varies directly as minus Z square by N square. The energy of electron in the orbit with the principal quantum number n varies directly as minus Z square by N square. Another important deduction also I am giving you. For hydrogen atom, En is minus 13.6 by N square electron volts, and En varies directly as minus 1 by N square. Very, very, very important deduction. I'll tell you the meaning of it. En varies directly as minus 1 by N square. Please copy
Sir,
that.
the value of En in this is in joules, right?
Here it is in joules. I converted this to electron volts. I have written here electron volts. How do I convert it into electron volts? 1 electron volt is 1.6 into 10 to the power minus 19 joule. So 1 joule, if you want, it will be 1 by 1.6 into 10 to the power of minus 19 electron volts. So in place of joule, I will substitute it, and finally I'll get this expression. En is equal to 13.6 Z square into minus 1 by N square electron volts.
Yes,
This
sir.
is in joules. Here is in electron volts. Yeah, you should have clarity about the units. Yes, Zoom is going to conclude. I will re-log in again. Don't go away. Another 5 minutes we'll take and then conclude.